Good morning students. Once again I welcome you to my video lectures on signals and systems. In the last class I just concluded the properties of signals by going through some of the properties, and then and also I explained what is mod sign. Now next is system, very important. As I said in the beginning itself, I have told that you can't separate system from signals. Signals and systems are very much interrelated. They're like fish and water. So no separate existence for fish without water, and for water also fish is very essential as far as its cleanliness is concerned, purity is concerned. So very much similar. Now I will explain. Now from today onwards I will take up systems. First I will define what is a system. What is a system? I will give examples. You understand system, and after understanding what is system, then you understand its properties. There are 6 to 7 properties. I will take up these properties one by one. System. What is a system? A system is a process. A system is a process for which cause and effect relations exist. So this is the definition of a system. You try to understand the system. I will give examples. A system is a process for which cause and effect relations exist. So to define a system, I require what is cause, what is effect. Cause means input. Cause stands for input signal. And effect is output. Effect is output signal, and sometimes output is also called as response signal. So this is the definition of cause, definition of effect. Cause means input signal, effect. So a system is a process for which cause and effect relations exist. In between cause and effect, you come across what is known as a system. I will give examples. Take for example a clinical thermometer. A clinical thermometer. So a thermometer is a device used to indicate ambient temperature, is it not? Clinical thermometer. So clinical thermometer is a system, and for which the cause is surrounding temperature, ambient temperature, surrounding temperature. So temperature is a measure of heat, that's all. So surrounding temperature, this is thermometer example. I am taking thermometer example. So thermometer is sensing surrounding temperature, and it responds to this surrounding temperature by going variation in the height of the mercury column. So mercury column undergoes change in height. Mercury column undergoes change in height. Change in height. So that scale is calibrated once again in terms of temperature. So here surrounding temperature forms input signal, and mercury column undergoes a change. So that is it responds. So a clinical thermometer responds to the surrounding temperature by undergoing change in height of the mercury column. So this thermometer is considered as a system, whereas surrounding temperature is the input signal and mercury column is the change in the height of the mercury column, that is output. Now I will take next example of what is known as heater. Heater is another example. A best example is a system. So heater, as you know that heaters are abundantly used in chemical processing industries, where for a heater we have to give electrical input. So electrical input means in terms of voltage. So voltage input. We have to give voltage input. So it responds to voltage input by undergoing change in temperature of the surrounding temperature. So it undergoes change in temperature. So a heater responds to a voltage input, that is electrical input, by undergoing change in temperature. This is another example of heater. Now in this way you can give a good number of examples. Take for example amplifiers. Amplifier. An amplifier is a process. So we use amplifiers in public address systems. In public address systems, we used to raise the level of music or human speech, is it not? So to elevate the height, we employ amplifiers. So for an amplifier, input is a low level signal, of the order of microvolts. Low level input. Now it undergoes change. For example, amplifier is having a gain of 100. Voltage amplification. If voltage amplification is 100 times, then the output will be high level output. It will be 100 times the input signal. So in public address system, amplifier is a good example for system. So just I gave 3 examples. And the next question is the signal may be continuous time or discrete time. So here the input and output signals will be continuous time or discrete time. So mathematical notation is important for you to remember. So I will give mathematical notation for a system. Now in textbooks there are 2 notations. This is one notation, x of t going to yt. In some textbooks it is given like this, x of t going to yt. That means xt is the input signal and yt is the output signal. This is one notation. In another notation is this. In some textbooks, y of t, it is equal to t times x of t. Y of t, t times x of t. What is significance of t? Means transformation. T stands for transformation. T stands for transformation. So if the signals are continuous time, so yt is equal to t x of t, where this notation t stands for transformation. This is one notation. Now in the same manner, discrete signals are also written like this. X of n goes to y of n. X of n goes to y of n, or y of n is equal to transformation on x of n. Now in the next class, having defined what is a system, now in the next class I will go through the properties. The properties are very interesting one. I will list some of the properties for you to remember. Memory. The system may, these are all called properties. Memory or memoryless. It may be memory or memoryless. Then causal or non-causal causal. Then property of time invariance. So here we come across what is known as time invariance property, then invertibility property, then linearity, memory is causal, time invariance, invertibility, linearity, and stability. These are all called properties. So very interesting to go through these properties. One has to solve more and more problems, then the concept will become clear. And in the next class I will take up these properties one by one. I will start with memory. Thank you.